We're going to do 7-2. Number 12 says sine squared x cosine to the 6x dx. I think I'll do a reduction formula to reduce either one of those. It doesn't matter, but I guess I'll reduce the sine. So I'm going to pull up the formula that reduces a sine. This doesn't fit under the camera very well, so you're going to have to look sideways. I'm going to use the one that ends up reducing the sine, which is this one here, number 8. So take a look at this. Take a look at this in your book, and then I'm going to write what I see on here. So using number 8, this becomes my m is, in this they start with the sign on number 8 is the m is 2 and the n is 6, and it equals the sine of m plus 1, so that'd be 3x, sine cubed of x, and then it's the cosine with 1 less, so that'd be 5x over m plus n, so that's 2 plus 6, that's 8. And then it's n minus 1 over m plus n. M minus 1 would be 1. 2 minus 1 is 1 over m plus n is 8 again. Integral. And this becomes the sine of 2 less. So that's no signs left. Sine to the 0 is 1. And cosine of the 6x dx. So then I'm going to go to the reduction formulas. Again, that's on page 383. And I'm going to use it on the cosine. And that formula that reduces cosine is the number 6. So I'm going to use number 6. And all of this stuff will stay. This stuff here. So we've got sine to the 3rd x cosine to the 5th x over 8 plus 1/8. Now I've got quite a bit to do here, and I don't know if I'm going to get it to fit on here. I was hoping I would. So the cosine reduction formula says cosine to 1 less. So that would be cosine to the 5th sine to the 1 x over n, which was 6. Then we have plus n plus 1. Let's wait, let me get the right one here. N minus 1, so that's 6 minus 5 over n, which is 6, times an integral. And that integral, I'm going to have to write it down here. It's the cosine of 2 less. Cosine of 6 minus 2 is 4 x dx. So then I'm going to use that same formula once again to reduce the cosine of the 4th. So now we've got to be careful to get everything here. So we have the sine cubed x cosine to the 5th x over 8. That's coming along with us. Then we have plus 1/8 times this. So that's going to be cosine to the 5th x sine x over 8 times 6 is 48. I'm also going to have 1/8 times this. That's 5/48 plus 5/48. And then I've got the integral of cosine of 4x, and I'm going to use the reduction formula once again. So that is, it it lowered the cosine power by 1 and put a sine x in. So 4 to 3, so it's going to be cosine 3x. We'll check the formula real quickly to make it, yeah. Cosine gets 1 less, that brings in a sine over n, and n is now 4. And then it's 1 less 3 over 4. Integral of 2 less power, so that would be 2 less than 4 is cosine squared x dx. And then there is a formula for the cosine squared. And there's actually a couple of them there. I'll just use the second one. Excuse me. So I'm going to have all of this sine cubed x cosine to the 5th x over 8 plus cosine to the 5th x sine x over 48 plus 5 over 48 times 4 is 192. Cosine to the 3rd x sine x, and 5 over 48 times this. The 3 will go into 48 16 times. Times 4 is 64, so we got plus 5 over 64. And then the integral of this is, according to that second formula, x over 2. This is a formula number 4, and it has 2 parts, and I'm just going to use the second one. X over 2 plus 1/2 sine x cosine x plus c. And that would be that. And there's possibly ways to clean that up or rearrange it and all that kind of thing, but I'm not going to take time to do that. I'm going to move on to 15. Now, always we'd like to think, maybe is there an easier way than just using formulas? And on this one, I think we can use, see, the derivative of tangent is secant squared. We don't have a secant squared. We just have a secant, so that'd leave a secant left. We wouldn't want that. And the derivative of secant is secant tangent. We have both of those. So, excuse me, I'm going to let u be the secant of x. Du would be secant x tangent x dx. So if I divide by the secant tangent, I get du over secant x tangent x is dx. So my problem becomes integral tangent to the 3rd x secant x dx is going to be replaced with du over secant x tangent x. So the secants cancel. One of the tangents cancel. So I have the integral of tangent squared x du. Well, u was secant x, so I need to write this somehow with secants. But if you remember back to the Pythagorean theorem, has several forms. One of them is tangent squared x plus 1 is secant squared x. So secant squared x minus 1 is what the tangent is. So this is the integral of secant squared x minus 1 dx, which is u squared minus 1. Du. So du, an integral, and that I can do. The integral of u squared is u to the third over 3 minus the integral of 1 is u plus c. But now to get this back in terms of x's, cu is the secant of x, so I get secant cubed x over 3 minus secant x plus c. Okay, now let's go to the next page of these. Next one was 42. So 42. So looking at these two, I could say, what is the derivative of cosecant? And that's negative cosecant, cotangent. I have both of those, but that would create odd powers. I also know that the derivative of cotangent is negative cosecant squared, and I got that. So that might be a little easier to use, and that will leave cosecant squared even power. So I'm going to let u equal cotangent x. Du is negative cosecant squared x dx. If I divide both sides by negative cosecant squared x, these cancel, and so this would become the integral cotangent. So now that'll be u squared, and then we've got cosecant to the fourth x and du over negative cosecant squared x. So that'll cancel two of those and put a minus out there. So I'm going to have minus integral of u squared cosecant squared x du. So I need to get this out of there and get it in terms of u. And just like the other one, tangent one, the last problem, we got the trig sine squared plus cos squared equals 1, Pythagorean theorem. If you divide everything by cosine squared, then that you get cotangent squared x plus 1 is equal to cosecant squared x. So this would turn into negative u squared, and cosecant is cotangent, which is u squared plus 1. So this would become the integral of negative, the integral of u to the fourth plus u squared du, which is negative u to the fifth over 5 minus, because that minus will carry through, or I could put parentheses, minus u to the third over 3 plus c, but u was cotangent x, so this is minus cotangent to the fifth of x over 5 minus cotangent to the third x over 3 plus c. And now 45. Well, what looks like it might be a nasty problem is actually pretty simple. First of all, this t will go if we let u equal t squared, then du will equal to t dt, and divide by 2t. So I'd get the integral t cosine cubed of u, and du over 2t is what dt will be replaced with. And the t's will cancel, and I get 1/2 integral of, this is an odd power, so I'm going to write cosine squared u cosine u du. And cosine is the derivative of sine, so I'm going to make a second substitution. I'm going to let v equal the sine of u. dv would equal cosine u du. And so there's the cosine u du, which is dv. And this is v squared, so this becomes 1/2 the integral of v. Oh, see, that's cosine squared, and this is sine. But cosine squared is 1 minus sine squared. So we'll have 1 minus v squared dv is all of that. So if I integrate the 1, I have a half already. 1/2, the integral of 1 is v, minus the integral of v squared is v to the third over 3, and then plus c. But we need to go back to a couple of steps. We've got to take it back to u's and then back to t's. So all the v's are sine u, so we got 1/2 sine u and minus 1/6 if I take the half times this, and this would be sine of cubed of u. And if I take it back all the way, the u's are t squared, so it's 1/2 sine of t squared minus 1/6 sine cubed of t squared plus c.